Thanks for choosing products from Synovision. Today I will introduce the operation of the Cardiac Coronary Artery Analysis plugin, short as CCA. In the patient management list, select the study for CCA. Then select the proper sequence in the series list below. Right-click, and select the Cardiac Coronary Analysis from the ADV process to enter the CCA interface. You can also click CCA in the function switch panel in the lower right corner to enter the CCA interface. When loading is completed, the following process initiate and complete automatically, including segmentation, extraction, and name of coronary branches, the stenosis analysis and so on. The results display on cardiac via image, CPA image, axial plane image, and straightened curved planar reformation image, short as SCPA. First, let's demonstrate how to edit the VIA image in the segmentation panel to show the origins of the coronary arteries. Select cardiac from tissue list. Adjust the opacity. Then hide the ascending aorta and coronary arteries. Use the cutting tools to cut the unwanted tissues. The cutting tools do not apply to the hidden tissues. Then unhide the ascending aorta and coronary arteries. The origins of coronary arteries can be seen clearly. We can use the preset coronary angiography positions to rotate the VIA image and send to film or save as needed. On the analysis panel, there are many manual tools to extract or edit the coronary vessels, such as single point extraction, manually draw the center line, edit center line, and extend center line, etc. We will introduce them one by one. For example, when the auto vessel extraction failed, we have to initiate manual extraction. The first tool is single point extraction. Find one point on MPA or VIA viewport. Place the cursor over the viewport. When the cursor become a crosshair, a green frame with regional zoom image appear at the same time. Long press the left mouse button on the point until the frame color turns into red. Then release the button. In the regional zoom frame, when the crosshair become a hand icon, move the seed point to the center of the vessel. After right-click to confirm, the frame turn back to green immediately. The new vessel with a center line is extracted simultaneously. The Extract Vessel Name dialog box pops up then. Select a correct name from the list, or manually enter the name, click OK. The extracted vessel name will be automatically added to the vessel list, and displays in the viewports. The stenosis information is automatically updated in the stenosis form. When single point extraction failed to extract the entire blood vessel completely, we can use multi-point extraction. For example, in the VIA or MPA viewport, find the slice of the origin of the vessel. Click the multi-point extraction button. And then a series operation same as single point extraction, to place the first seed point. After then, scroll the mouse wheel or the slider on the right side to page up or down to implant the new seeds one by one along with the vessel. The software automatically traces the blood vessel center line between two seed points. After all seeds are completed, click OK on the bottom of viewport the vessel with a centerline is extracted. And the Extract Vessel Name dialog box pops up simultaneously. Name it and update all results. Sometimes, the presence of soft plaques may cause lower CT values in the blood vessel, which may cause the multi-point extraction to fail. In this case, we can manually draw the center line to trace the center line. In the MPA viewport, find the slice of the origin of the vessel. Double-click to enlarge the viewport. Click the Manually Draw the Center Line button. The operations are the same as for multi-point extraction. Double-click the right mouse button to finish drawing. Click on the sepia curve viewport. Activate the center line and double-click to enlarge the viewport. Because the software uses straight lines to connect two seed points. After the drawing is completed, you need to edit the center line on the sepia curve. Click the Edit Center Line button. Rotate at different angles. Hold down the Ctrl key to add new seed points. Change angles and drag the seed points. Make sure all seed points are in the center of the blood vessel. The Edit Center Line function can also be done at VIA and axial plane viewports. Extend Center Line is to extend the selected vessel. Select the vessel that needs to be extended. Click the Extend Center Line button. Turn the page to find the Extend Point of Vessel on Axial Plane Viewport or VIA Viewport. Press and hold the left button. Move the seed point to the center of the vessel in the zoom frame. Click the right button to confirm the blood vessel is extended. You can perform multiple extension operations after the extension is completed. Click the OK button to complete. Combine Center Line is to connect two vessels, inactive by default. Press the Ctrl key on the keyboard and select the two vessels intent to connect. The tool is active and then click the Combine Center Line button. The connected result will display on the viewport. If the stenosis is found in the vessel, we can adjust the lesion line and reference lines. When the cursor changes to a hand icon on sepia or 3D viewport, or a double direction blue arrow in the straightened viewport, adjust the reference line position. The 5 slice reference lines in the vessel sepia viewport, corresponding to the 5 vascular cross-section images above. In the sectional images shows information such as area, equivalent diameter, maximum diameter, minimum diameter, and position. Scroll the mouse wheel to change the position of the reference line, and the information on the cross-sectional images will update accordingly. At the moment, the stenosis analysis results can be seen in the stenosis form. Contour drawing, to cancel the previous contour, and manually draw a new contour, on cross-sectional viewpoints. Click the button. Draw a contour line, along the blood vessel boundary, by long pressing the left mouse button in the vessel cross-section images. After drawing is complete on 5 images, click OK to complete the drawing. The information of the vessel stenosis form is updated accordingly. The plaque tool can help us to distinguish plaque types based on CT values. Click the Plaque Definition button. The interface changes to evaluate the plaque. The pseudo color bar appear on the left side of the CPA viewport. Click on the vessel to define the start point and end point. Once the plaque analysis range is defined on vessel CPA image, the plaque name will be displayed in the plaque list in the function panel area, and the stenosis form changes to plaque form as well. The plaque can be deleted by the delete button above the plaque list. In CPA image, different plaque components are marked with different colors. The pseudo color scheme can be changed by double-clicking the pseudo color bar. This plaque button to switch the highlighted plaques display or not. Plaque histogram shows the volume distribution of the identified plaque according to the selected pseudo color schemes. The contour line here represent the inner border. Therefore the plaque form is calculated from the inner border of the arterial wall. If you want the calculation changes to the outer edge of arterial wall, you can draw the contour line manually. The plaque form and the pseudo color both changed to the outer border. In the CPA viewport, right-click on CPA, switch to other display modes, such as longitudinal section, coronal image, sagittal plane, and vascular section, etc. In the lower left corner, allows to switch between 2D, MIP, AIP, MinIP display modes. In the lower right corner, allows to adjust thickness and modify the window level and width as well. For example, we can change to MIP display mode, adjust thickness, and longitudinal section view. In SCPA image, find the stenosis, drag the lesion line to the stenosis, and observe coronary plaques in longitudinal view. Save image. In the lower left corner of VIA viewport, allows to switch between VIA, MIP, AIP, MinIP, and DSA display modes. Right-click VR in the upper left corner. Switch between VIA and virtual endoscopy. Press play key to browse the internal surface of blood vessel. Above the blood vessel list, click Batch button. Drag on the slide bar to define the start and end point. Then you can batch save the endoscopy images. In the upper right corner where it displays coronary aorta, right-click mouse to switch between heart and coronary aorta only. In the VIA viewport, right-click to open the drop-down menu. Select Common Posture of Coronary Angiography, and then corresponding angle from the secondary list. The result is displayed in the upper right corner of the window. After above steps are completed, if the result and images would be saved, including the stenosis form and plaque form, select the viewport with the result to be saved. Click the Save icon in the lower right corner, and select the Save path on the pop-up window. If the vessel's name is intent to save, select Save Screen to Database. This is Save Image to Database. This is Save Screen to Database. Finally, the CCA plugin also provides a standard structured report. Click the Send to Report button in the function panel to open the report editor. At the top of the report editor, you can switch between the vessels. Below is the stenosis list. You can add the analysis results here by adding the button. Report will automatically read the stenosis and stenosis rate. Select from the drop-down menu of location, stenosis level, plaque type, according to the actual situation. According to judgment, the doctor writes information, such as the degree of danger in the remarks. The functions of plaque defining in the bottom are the same as analysis step. You can send the selected image to the standard report by clicking the Add Image to Report button. After the above editing is completed, click the Send and Generate Report button to generate a standard report. Save, print or export the report as needed. Now I will introduce the user interface and the less commonly used functions. The CCA interface is divided into the viewport on the left side and the toolbar panel on the right side. At the top is for the study and series loading selection. Under it and on the bottom, there are some common tools for post-processing. The specific tools for CCA locate in the middle area. This is the layout setting. There are 3 orientation buttons for VIA image. They are axial, coronal, and sagittal. There are the cutting tools and the semi-auto extraction button to complete a series operation including setting seed points, auto segmenting and extracting. If the result of the automatic analysis is not satisfying, it allows to initiate the semi-auto segmentation process. Click the Set Seed Points button. A dialog box pops up prompting user the seed point placing position and informing all previous results will be cleared. Click Yes to initiate segmentation and extraction. Placing the seed point at the root of the ascending aorta. The segmentation and extraction of the heart and coronary vessels will be run automatically. If semi-auto segmentation result is still not acceptable, the manual tools such as manual extraction, hole filling, erase, and staining tools could be used to separate the body, heart tissue, ascending aorta, and coronary artery. Here, taking the coronary arteries segmentation as an example, select the coronary aorta in the tissue segmentation list. Tick off other structures to make them no-show. Browse the image in the MPA viewport to find the coronary arteries. In this case, we choose ACA. Click the Manual Extraction button. The default threshold value is 50. We can change as needed. When the cursor becomes a crosshair, hold down the left mouse button and press the Shift key on keyboard at the same time. The green area spreads until the button is released. We can extract other coronary arteries in same way. After then, the corresponding pixels are displayed in the VIA image. If there are gaps inside of stained tissue, click the Hole Filling button to fill the gaps, and the Expand button to expand the extracted vessel outward. We can use the Erase tool to wipe the unwanted tissues. The radius is 10 mm by default, which can be adjusted as needed. The same method can be used to extract and edit other tissues. The middle area with CCA specific toolbar are divided into Segmentation Panel, Analysis Panel. Analysis Panel is by default. The extracted and named coronary branches display on the vessel list. Below the list there are manual extraction tools and edit tools. Below is the plaque name list. Once the plaque analysis range is defined, the plaque name appears in the list. This plaque button to switch the color schemes and the highlighted plaques display or not. The plaque histogram is designed to observe the plaque CT value volume statistical distribution range. The rest of buttons are the commonly used tools for post-processing, such as overlay to determine the four-corner information display or not, linkage, crosshair, box, center line, contour line, orthogonal, reset, send to film, send to report, save, tool, and the drop-down menu of preset window width and width.